Hello and welcome to UE4 Tuts for you. So I have decided to start a new VR related tutorial series. In this tutorial series we will implement VR related gameplay mechanics like physics based hands, force grab objects, object grabbing with proper weights, full body IK, character locomotion and many more. So guys, if you like my content then do subscribe my channel, and also you can support me on Patreon for making more content and videos. So let's get started guys. So here I have my default VR template project. Now let's open motion controller map. So here I have opened my motion controller map and I have implemented some changes over here. First I have removed the default pawn from here and add some cubes over here with some weight like 30 kg, 20 and 10 kg. Now let's make our character class and implement the physics based hands. I will create a new folder and call VR physics based hands. So here I have my folder. Now I'm gonna right click and create blueprint class, and base class will be my character. I will call this VR underscore physics hands. Here is my VR player class. Now I will create a new game mode or implement the gameplay logic. So here is my game mode, VR physics based game mode, and in the default pawn class I will select my VR physics hands character and set it over here. So here is my game mode is set up. Now let's open our VR player character. So here I have the default character class. Now I'm gonna select capsule component and add a motion controller. I'm gonna call this right motion controller, right hand underscore motion controller, and duplicate this. Let's first add the scene component that will be our root, and under the root we will add a new camera component and select the root, set the Z units to -90 units so that we will start from proper floor level. Now I'm gonna select my right hand motion controller and paste it over here underneath my root and set the default position so that it will be at the ground of the capsule component. Now I'm gonna duplicate my motion controller and call this left hand underscore motion controller. Select my right hand and our motion source I'm gonna select right, and for the left hand motion controller go to motion source and select left. Now my both motion controllers are set up. Now let's add a static mesh for debug, for checking where our controller is in the world space. I'm gonna call this right hand mesh, and the mesh will be our cube. I'm gonna set the scale to -0.1 will be fine. Now let's open the material and set the, I think default material is fine for our right hand mesh. Now underneath the collision, set it to custom. Then in the collision enabled, we will select QE only, no physics collision, and ignore all the channels. So make sure you set the collision enabled to QE only and ignore all the channels for right hand mesh. And similarly, now we will add static mesh for our left hand. Here is, I'm gonna call this left hand underscore mesh, and for the left hand we will use the same cube. Scale will be 0.1, and we change the material for this to something like this, light blue. And same for the collision, go to custom, collision enabled will be QE only, and ignore all the channels. So here we have set up our both motion controller and static meshes. Now let's check this and let's check the result in the world. So I'm gonna open my motion controller map, and in the world setting we will add our game mode that we will just create, VR physics based game mode, and grab the player start and set it over here. So here is our player start. Now let's check the result. I'm gonna open my motion controllers and play in VR. So here you guys can see I have set up my both motion controllers with these right hand and left hand cube. So now let's add some movement functionality so that we can traverse around the map. For adding some movement, I'm gonna open my VR physics hand, then go to edit and project settings. So here is our project settings open. Now we will go to input, and from here we will use axis mapping. So here is default axis mapping, motion controller thumbstick right Y and motion controller thumbstick right X. And underneath motion controller thumbstick right Y, here is Vive, HTC Vive trackpad Y. So I am using HTC Vive, so you can set according to your own hardware. And for motion controller thumbstick X, I have Vive trackpad X. We will use these two axis mapping to control our movement logic for our character. So here I will right click and select motion controller thumbstick right Y axis events, and motion controller thumbstick right axis event. Now I will grab my camera component, get its world rotation, and grab the forward vector and add movement input. So the movement input for my thumbstick right Y, this will be my forward vector, and axis value will go to scale value. Now I will duplicate add movement, and for my motion controller thumbstick right X, I will grab the world rotation and get right vector of my camera component. So here is our basic movement for our character is set up so that we can traverse around the world. Now I'm going to character movement and set the max walk speed to, I think 150 will be fine. Now let's check the result. So now let's play, and here I have my motion controller, and when I move my thumb over my thumbstick, right motion controller thumbstick, my character moves according to the camera position, camera rotation. As you guys can see, I can move forward, backward, and left, right. So here we have set up our character movement logic. Now let's open our physics based hand character and implement the physics based hand logic. So now I'm gonna go to viewport and select my right hand mesh and add a new component that will be our physics constraint. I'm gonna call this right hand underscore physics constraint and set the properties of physics constraint. First, disable collision will be true and linear limits will be free in all axes, and linear motor position target select all to true, and set the strength to 1000, and velocity target will be 500 for this, and for the angular drive mode we will select twist, swing, and same for strength 1000, and the target velocity will be 500. So here we have set up our physics constraint. Now let's add our hands skeleton mesh for our right motion controller. Now I'm gonna select right hand motion controller and add a new skeleton mesh. I'm gonna call this right hand underscore skeleton. So here is our right hand skeleton, and for the collision let's set to custom, and collision enabled will be our collision enabled query and physics both, and set the pawn to ignore. So here I have my physics asset for right hand skeleton, and I have added the basic cube collision to my right hand and set the weight to 2 kg. Now we will set up our logic for physics based hand. First, at begin play, let's grab our right hand skeleton and set physics enabled, set simulate physics and set this to true. Now let's grab our right hand physics constraint and set constraint components. Component 1 will be our right hand mesh and component 2 will be our right hand skeleton mesh, and 1 will be our hand underscore R. So make sure you have select the right hand mesh and collision enabled to QD only. Now let's check the result. So here you guys can see my right hand is not properly functional, but it works fine. It collides properly with physics, but it's behave awkward. So now let's fix this issue. So our right hand is not properly functional because we don't set the physics constraint properly. So first I'm gonna select physics constraint and set the velocity strength to 50 instead of 500, and same for the velocity. So you guys can play around with these values, and when you feel fine, then set those values according to your need. Then after setting the values, I'm gonna select my right hand skeleton and go to its location, and in the x-axis set it to -10. Now let's check the functionality again. So here you guys can see my hand is properly working and properly colliding with the physics object. Now let's add the same functionality for our left motion controller. I'm gonna select my left hand motion controller, and so I'm gonna select my right hand skeleton, copy and paste it over here. Set the name to left hand underscore skeleton, set the location, and in the x-axis set it to -10. And for left hand we will set its world scale in the z-axis to -1 so that it looks like a proper left hand. So now let's add the physics constraint for our left hand. I'm gonna select my right hand physics constraint, copy it and paste it over here and call it left hand physics constraint. Set its location, and the values will be fine as we have set for the right hand physics constraint. Now let's go to event graph and add begin play. First we will get our left hand skeleton and set world scale to 1 in the x, 1 y, and -1 in the z-axis. Now duplicate all the remaining functionality over here, connect this and simulate physics for our left hand skeleton. For the target, we will set left hand physics constraint. Component 1 will be our left hand mesh and component 2 will be our left hand skeleton mesh. Bone name will be hand arc. So this is our left hand motion controller setup. Now let's select left hand mesh and right hand mesh, go to rendering and hidden in game to true, so that we can properly see our both hands only, not the cubes. So now let's check the result, and so here my both hands are properly set up with physics. As you guys can see, it behaves properly, and when I interact with the objects in the world, it behaves properly to the physics and collision accordingly. You guys can see here. I can properly interact with every object and my hands didn't pass through the objects. So if you want to use animations for your skeleton mesh, you can create a new animation blueprint for each of the hand and set the animations accordingly, and it works properly fine. So at the end, thanks for watching guys. I hope you guys like this video. Don't forget to subscribe my YouTube channel, and also you can support me on Patreon for making more content and videos. And in our future tutorial, we will set up our physics space force grabbing and physics objects grabbing with proper weights like Boneworks and Half-Life Alex. So thanks for watching.